a method for solving systems of equations. It's called substitution. And this example sort of tells it all. If you have two equations, like this one and this one, notice that y is equal to 9x. Think of that as a statement. Y is 9x. They're the same thing. They're interchangeable. And if y is 9x, then when you look at y plus x equals 43, think about right there, instead of y, we could say 9x. And that's substitution method. As soon as we do that, we get an equation with one variable that's easily solvable. So let's try some examples. Here's one that looks a little more confusing than my previous example, but it's going to work out the same way. The first thing is to isolate one of those four variable expressions that you see. I see x, 4y, 5x, and 2y. One of those has to be isolated before we can use substitution method. So I always pick the easiest thing to get by itself. I'm going to choose x because the coefficient, or the number multiplied out in front, is just 1. I won't have to divide by any number to get x by itself when I'm solving. So let's try it. We want to get x isolated, so we're going to add this entire expression just to move it to the other side. We don't know the value of x, but we have isolated x. We've solved the equation in terms of y. So now we've got this expression that's the same as x. They are interchangeable. So look in the other equation and find the x. Here's where x is. I like to surround it by parentheses, and then imagine rewriting that equation and expand those parentheses so that they have more room. Now substitute this new value of x into the parentheses. That's where x used to be. Now it's 7 plus 4y. And now we've got an equation that only has y in it as variable, so let's solve for y. The first step is to distribute that 5 really carefully. Okay, I've multiplied both of those things by 5. Okay, combine like terms. Still got a 35. I'm going to subtract that. So what's left? I have 22y is equal to 66. Now I divide by 22 and find that y equals 3. So we've got one of our solutions. Now we use substitution again to find out what x is. You can take this 3 and plug it into either of these original equations for y and then solve for x. Well, I still think that first equation is going to be the easy one. And in fact, I love the fact that I changed it already so that x was isolated. Let's use that. You can plug in the 3 anywhere you want, but this is the best place, right here. Let's just simplify that right side, and we get x equals 19. Now there's a special way that we write our solutions to systems. We write them as an ordered pair, because remember, this is a point where these two equations intersect. And so I want it to look like a point. And that's the answer, I think. Now here's what you don't know. You don't know if you've made a mistake in all of this work. Look at all the operations we just did. What if we made one little arithmetic mistake? Then this is the wrong answer and we wouldn't even know it. But we can check our answer to find out. Remember, one of the characteristics of a system is that this ordered pair can be plugged in to either of the original equations and make a true statement. So what I'm going to do is I'm going to now plug it into that second equation and see if it works in there. 5x plus 2y is supposed to be equal to 101. Let's find out if it really is. So 5 times 19, that's 95, plus 6 more, and in fact that is 101. So it looks like we have the right answer. You should always check your answer. Since I got the 3 by using the first equation, I plugged it into the second equation to check my answer. Let's try another example. Okay, the first step is to isolate one of the variables, but look at this. We've got an isolated y here and an isolated y here, so this is going to be super easy. What you want to do is take the expression that's equal to y here and just plug it into the other y. So remember how I used parentheses before? So I'm going to represent that y with some big set of parentheses. That's where y used to be, equals 4x plus 33. And in those parentheses, I substitute this other expression that's also equal to y. Now there's nothing to distribute, so I can just drop the parentheses and continue. And we solve the way we always have. I'm going to go ahead and add 3x to the other side because I like to make things positive. You could subtract 4x instead if you prefer that. What's left is a 5 and 7x plus 33. So now I'm going to subtract 33 from both sides. That gives me negative 28 is 7x. So let's divide by 7 to get our final answer. It turns out that x is negative 4. So now I'm going to substitute that into one of the original equations. Let's just use that first equation. Y equals negative 3 times x plus 5. And we think x is negative 4. So let's see what that makes. 12 plus 5. So it looks like y is 17. Let's write our answer as an ordered pair. And we think that's the final answer, but you would be foolish not to plug it back in, so we're definitely going to do that. Let's take that second equation to check our answer. So if that's true, then 17 has to be equal to 4 times negative 4 plus 33. Let's see if this is a true statement. Negative 16 plus 33. And in fact, if you take 33 and subtract 16, you really do get 17. So it appears to be the correct answer. I'm satisfied. Let's try one more example. So remember, the first step is isolate a variable. I see that there is one that is already isolated, so I don't have to do anything else. I'm going to use that. Since y is equal to this expression, I'm going to plug it in to the y in the other equation. So let's rewrite that first equation but expand those parentheses. And now I take this expression and put it into the parentheses instead of y, since it's equal to y, and solve for x. Simplify the right side and continue. I'm going to add x to both sides. Divide by 7. Okay, it looks like x equals 8/7. That's probably not the kind of answer that you want to see, but it's very common to get fractions as solutions. So don't be scared about it just because we got a fraction. That doesn't indicate that you got the wrong answer. We do need to proceed with the problem, so we're going to have to plug that in for x in one of the equations. Let's plug it into this one, shall we? 3 times 8/7 is equal to y, and that's 24/7 equals y. So we believe our answer is 8/7, 24/7. But let's check it and see. Remember, I just used this equation, so now I'm going to use this one to check. All right, plugging in our current values that we think are correct, we have 8 minus 8/7 is equal to 2 times 24/7. I'm just going to simplify that a little bit. 48/7. Now I'm just going to go ahead and get a common denominator over here. 8/1, if I multiply by 7/7, can be rewritten as 56/7 instead of this. Okay? And I proceed with the problem. So 56/7 minus 8/7 is 48/7. And in fact, that is exactly equal to 48/7. So I have checked my answer. It appears to be correct. Let's review the steps for solving with substitution. The first step is to isolate one of those variables. You're going to see 4 variable expressions in most problems, and you need to pick one of the variable expressions that looks like the obvious choice. Pick the easiest one to get that variable by itself. Once you have a variable expression like this, substitute this into the next equation. Okay, that's step 2. Now you're going to have an equation that is all one variable, and you can solve for it. Once you've got that value, like x equals 9, substitute that value into an equation to find the second value. Go ahead and record your answer always as an ordered pair. We want to see this. That reminds us that what we're solving for is the point of intersection. You need to check your answer every time. This is really important. I can't stress it enough. When you've gone through this much work, you're going to feel like it must be correct, but in fact it's so easy to make one arithmetic mistake and have a wrong answer that you don't even know is wrong. So plug it into the other equation. If you get a false statement, you need to check your work because you've made a mistake somewhere. So go back to the beginning and try it again and see if you can find out where that little mistake is. And with practice, this becomes a really simple process. So go try it.